Moving on to lesson 5, which has equations with variables on both sides. So we're going to solve problems like that. Then we're going to do a real world problem and then identify the number of solutions of an equation. First we have 7 minus 8x equals 4x minus 17. So this looks different from the ones we've done before because usually you have the x only on one side and you just have to isolate it. Now we have to kind of get to that point because we have x on both sides here. You don't have to do this, but I usually move the x's to the left and then the other numbers to the right with addition and subtraction. You could do the other way around, the x's over here and these numbers over here. You'd still get the same answer. But let's do it this way first. So let's move the positive 4x to the left, so I'd do minus 4x on both sides. Okay, so then this turns out into 0. I have negative 8x minus 4x, which would give me negative 12x. And I have positive 7 over here, so I'd do minus 7. Subtract 7 from that. So negative 17 minus 7, 2 negatives, so that'd be negative 24. So negative 12x equals negative 24. Let's move that over here so I can solve it. Divide both sides by negative 12. That would give me a positive x equals 2 negatives. So that would give me positive 2 then too. So for this problem I have 9x minus 5 equals 1/4 times distributive property, so 16x plus 60. So let's do that distributive property first. So 1/4 times 16, I know 1/4 of 16 is 4, so 4x. 4x plus 1/4 of 60 then, which would be 15. So that's my right side. So I have 9x minus 5 equals 4x plus 15. So I'm going to move the x's over to the left again. So that would give me 5x over here. Minus 5 equals 15. So I'll move the 5 over then. So plus 5 here. Plus 5 here. So this would cancel out. So I would have 5x right here. And then 15 plus 5 would be 20. Divide both sides by 5. That would give me 1x equals 20 divided by 5, which is 4, or just x equals 4. Let's do a real world problem then here. A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold has been decreasing by 4 cars each year. So if these trends continue, in how many years will the number of new cars sold be twice the number of used cars sold? So whenever you have this equation, I like to start with the equal sign. On this side, I'm going to start with new cars. On this side of the equal sign, I'm going to have used cars. And then let's work our numbers from there. So we know we start with 78 new cars. We start with 67 used cars. We also know that this is increasing for new cars by 6 every year. So if it was 2 years, it'd be 12, 3 years, 18. So x is our variable for time. We add 6 times x. So I know used cars are decreasing by 4 each year, so I would do minus 4 times x, which is the years. So if it's 2 years, it'd be minus 8, or 3 years, it'd be minus 12. So are we done yet? We're not quite done. Remember, this is just equaling each other. I want this to be double what that is. So I want to multiply this times 2 and have it still be equal or less than the new cars. So I'm actually going to put times 2 on this side. So I'm putting parentheses and multiplying this times 2 with distributive property. So let's do that distributive multiplication to start solving this problem then. 67 times 2, that would be 134 minus, moving that subtraction over, 2 times 4x, which would be 8x. Then we have 78 plus 6x on this side. And that equals 132 minus 8x. So I'm going to move the x's over here. So let's add 8x over here. That gives me a total of 14x. And that equals minus 78 from both sides here. So that would give me a total of 132 minus 78. That would be 56. So now I have 14x equals 56. Divide both sides by 14. And that would give me a total of 4. So x, remember, was years, so it would be 4 years. that would take to double the new cars compared to the used cars. This is a little bit different here. We need to identify the number of solutions of an equation. Sometimes there are no solutions, sometimes there's infinite amount of solutions, and you'll kind of see what happens here with these ones. So let's solve this distributive property here. So 3x equals 3 times x plus 3 times 4. So 3x plus 12. I would subtract 3x here minus 3x here. So that would give me, wait a minute, that would give me 0x, or just 0, right? Equals 12. So this means that there are no solutions because we know that 0 can't equal 12. So we're going to say no solutions. Here we have 2x plus 10 equals 2 times x plus 5. Let's do distributive property here. So I have 2x plus 10 on the left equals 2 times x, which is 2x, plus 2 times 5, which is 10. And would you look at this? 2x plus 10 equals 2x plus 10. So if I subtract 2x here, if I subtract 10 here, let's see what happens. Minus 2x, 2x minus 2x would be 0. 10, this would be plus 0. Equals, this would also be 0. Then plus 0 again. So this would be 0 equals 0. And when this happens, that means that the equation is infinite solutions, meaning that the solutions will go on forever. So you would say infinite.